Hello and welcome. Have you ever wondered why materials can completely change their properties, like their color, just by becoming incredibly small? The secret lies in a fascinating and mind-bending phenomenon from the quantum world. Today, we are going to explore the concept of quantum confinement. So, what is it? In simple terms, quantum confinement is what happens when you trap a particle, like an electron, in a space that is extremely small. We're talking about a space just a few nanometers wide, close to the size of the particle itself. In a large piece of material, an electron can move around freely, almost like a person wandering in a huge, open field. But when you shrink that material down to the nanoscale, the electron becomes confined, like that same person being put into a tiny closet. Its freedom of movement is severely restricted, and this is where things get weird and wonderful. The reason this confinement has such a dramatic effect is because electrons don't just act like tiny balls, they also behave like waves. This is a fundamental idea in quantum mechanics called wave-particle duality. Think about a guitar string. When you pluck it, it can only vibrate at specific frequencies, creating specific musical notes. A wave has to fit perfectly between the two fixed ends. It's the same for an electron's wave. When it's confined in a tiny box, only certain energy levels, or wavelengths, are allowed to exist. These distinct, separate energy levels are called quantized energy levels. As the box gets smaller, the gap between these allowed energy levels gets bigger. This energy gap is called the band gap. A larger band gap means you need to hit the material with more energy to get an electron to jump up to a higher level. When that electron inevitably falls back down, it releases that extra energy as a particle of light, a photon. Here's the magic: a bigger energy drop creates a higher energy, bluer photon. A smaller energy drop creates a lower energy, redder photon. This means we can take the exact same material and make it glow different colors just by changing the size of the particle. Smaller particles have stronger confinement, a bigger band gap, and emit bluer light. Larger particles have a smaller band gap and emit redder light. This effect is the technology behind the brilliant colors in QLED TVs, which use tiny semiconductor crystals called quantum dots. It's also being used to develop more efficient solar cells and for advanced medical imaging. In essence, quantum confinement is the rule that says shrinking a material down to the quantum realm fundamentally rewrites its properties. Thank you so much for joining me to explore this amazing topic. If you found this explanation helpful and want to dive into more science concepts, please consider showing your support by liking this video, subscribing to the channel, and ringing that notification bell. It truly helps a lot. See you in the next one.